Okay, so suppose the total cost and market price, you produce X units, and your total cost is 2/5 X squared, excuse me, plus 4X plus 44, and the market price is 1/5 times 62 minus X. Find the level of production that maximizes profit. So this is the main application in this section. So all you really have to know is, well, what is profit, right? The profit function, now in economics, it's usually given actually the symbol pi, the Greek letter for p, essentially, because they don't really use trigonometry, and so if you use pi, there really won't be any confusion. But since in this class we do use trigonometry, I'm just going to use a capital P for profit. Now, what is profit? Profit is the amount of money you still have left over after you subtract your costs, right? So profit can be negative, right? If you actually spent more money than you made, profit can be negative. So symbolically, your profit is your total revenue minus total cost. Okay. Now, what is revenue? How do I get revenue from this problem? Because the problem did not give me what the total revenue was. How can I actually get it myself? Price times X, that's right. So X times little p of X. Right, so quantity times price. Okay, so now we can actually write down what my profit function is. So X, so let's see, 1 over 5 times 62 minus X, that's quantity times price, and then minus the cost function. Okay. And then just doing a little bit of algebra, let's do that here. So 62 X, oops, 62 over 5 times X minus 1/5 X squared minus 2/5 X squared minus 4X minus 44. Okay, so we have here then negative 3/5 X squared minus, so this is really 20 over 5. So we get here minus 42 over 5, sorry, plus 42 over 5, X minus 44. Okay, good. And now we just need to maximize profit. Just to be clear here, on what interval are we maximizing profit? Well, remember, what is X in this case? X represents the level of production, so the units that you have produced. It's not quite negative infinity to infinity. 0 to infinity, then in fact, you can actually include 0. You are allowed to produce nothing. So these problems will always have the same interval, right? Profit is always maximized on the interval 0 to infinity, including 0, unless otherwise specified. Okay, so let's find p prime of x. We get negative 6 over 5x plus 42 over 5. Set that equal to 0. And we get here x equals 7. We get, in fact, one critical number. And now let's just verify that this really does give us the maximum profit. So notice that these optimization problems in the econ and business section, they are a little bit easier because there's no such thing as the objective, the constraint, and all that, right? Because usually the objective is very straightforward. Like here's the profit function, or here's an average cost function. Just maximize it. So usually the function itself is a very straightforward thing to get. It's you. There's really not a word problem that you have to solve, like the fencing problem we just did. So those types of problems are usually a bit harder. That's why we only needed a few minutes to actually do this problem. Okay, so I'm again going to let's actually just review both methods. Method one, assign chart for P prime. Shape of P. My critical number was 7. Test points, let's choose, say, 1 and 8. And my profit derivative was negative 6x plus 42 all over 5. So substituting in 1 gives me a positive number, and substituting in, say, 8 gives me a negative number. Good. Or I can just use the second derivative. So here's my first derivative. So my second derivative, note that P double prime of x is just negative 6 over 5, which is negative for all x greater than or equal to 0. So either of these two methods, so now we can actually conclude, so x equals 7 gives max profit. Right? They both give the same conclusion, right? Here I get a local maximum, and since it's the only critical number, I therefore get a global maximum. And over here, I get that the function is concave down for all x because the second derivative is negative. So therefore, I must have a maximum, right? So either of these two methods gives the same conclusion. So, whoops. So x equals 7 gives the maximum profit.